G'day guys, today we have a tutorial on a script which allows you to automatically detect sunrises and sunsets. It's quite a coarse script in terms of its methodology, in that it divides the particular image, in this instance, up into a grid of 5x5, and then uses the amount of low cloud, medium cloud and high cloud in each of the grid locations to determine if there will be a sunset. Or a sunrise on the way, based on the forecasts. So that's the basic premise of what's going on. So just a bit of theory before we jump into this further. So in my experience, the best sunsets and sunrises, this is just something I found off Google Images, by the way, the best sunsets and sunrises generally seem to occur when there's a decent amount of, you would say, mid to high cloud, mostly high cloud, where there's nothing that's sort of low and in your way to block you from seeing the high cloud, and there's a gap on the horizon that allows the sun to sort of come up from underneath. I know that the sun's never really underneath, but, you know, following the curvature of the earth, the sun sort of pokes through underneath and highlights the underneath of the high clouds. That's when I see my friends post on Instagram, that's the situation that I always tend to see when I then look at what the cloud forecast is for that particular spot where they took their special sunset photo, is that they had high cloud that was not blocked or interrupted by anything else between the viewer or between the high cloud and the sunset, or the sun itself. So what I've done is I've used some captures from a website which forecasts low, medium and high cloud to a fairly high standard of accuracy, and what I've done is downloaded these images, cropped them so it doesn't have the bars at all, and then divided these images up into the 5x5 grid and stated that this section here is central south, then we have southeast, southeast east, southwest, southwest, west west, which I know is a little bit cumbersome to say, but that's just the naming scheme that I've gone with, and obviously you can change this in the script to whatever you want it to be. So let's look at how that manifests itself in the script. Now, as I mentioned, this is a Python script. I've got this open in QGIS, though, I mean, we don't need this to be open in QGIS. It doesn't have any requirements for QGIS. It's just a convenient way for me to look at and edit Python scripts. So, apart from some importing, the first real thing it does is, as I mentioned, I got these cloud density images from this website, from a website. And these lines here basically aim to grab the images from the websites in PNG format. Now, what you'll notice is that they're different based on the time. Keep in mind that, you know, if you are not in Tassie or Australia, then you may want to you'll probably end up using a different website and maybe grabbing the images in a different way, but this is just an example of how you would do this. So I have the times of 32 hours ahead and 20 hours ahead, which for when I run this corresponds to tomorrow's sunrise and tomorrow's sunset, and we have both the high, mid and low cloud. So downloading 6 different images is basically what the first part does, and so they look kind of similar to this, where you've got blue for areas that are clear and then red for areas that are cloudy. Basically it just downloads 6 versions of those. Next, there is some processing through PIL. I haven't had a huge amount of experience with this before, but it's pretty straightforward. Basically what it does is it does that cropping that I mentioned earlier on, and then it resizes the image from however many pixels it was to a 5x5 pixel image, which effectively means, and by the way, it's got bicubic interpolation in there to make sure that there's sort of a blend of all the pixels combining into one. So basically, by having that 5 by 5 pixel image, it effectively functions as placing a grid, a 5 by 5 grid, over the original image to see the amount of cloud within that area. And then further down, we have the definition of the coordinates, the pixel coordinates. That is starting in the top left. So let's just pretend that this actually is a 5 by 5 pixel image. So you've got pixel 0, 0 here. So then you'd have pixel 0, 1, 0, 2, 0, 3. And so I've said that the coordinate southwest west is pixel 0, 3 in the 5 by 5 pixel image. And I've defined a series of different coordinates there. They're just the 5 that we mentioned a moment ago. And now we've got some dictionaries which store something that we're going to look at a little bit later, which is this red-blue ratio, which is something that I made up. And it's not really a ratio, it's basically just a difference. In order to quantify the cloudiness in these images, I've taken the difference between the red value and the blue value of each of these pixels. So for example, the red difference between red and blue, or as in the red minus the blue for this pixel here, would be a significantly positive number, whereas here it would probably be a negative number. That is, there's more blue in the pixels here than there is red in the pixels here. So that's what this effectively will do later on. We'll get to that soon. But these dictionaries basically allow you to store for each particular image, in this case the high cloud during sunset time, and for each of the 5 coordinates that we decided were relevant, the red-blue ratio, which we're effectively calling cloudiness. And then there's some other work down here. I don't fully understand how this works, but this effectively here transforms the dictionary to make sure that you can refer to each row. These are basically 2 by 2 arrays, by the way. It means you can refer to each row within the dictionary using the name. That is, you can call upon high, southwest, west to be able to get the red-blue ratio you want later on. Now there is a defined function, a function that I've made here, which allows you to get the red-blue ratio difference for a particular coordinate and a particular image. If you pass through the name of a coordinate and the name of an image into this function, it determines the difference between the red and the blue and spits that back out. And so that's called upon several times here in order for each of the relevant pixels in the sunset image, the low cloud sunset image. It determines, this thing here runs 5 times in my instance, it determines through this function what the difference between the red and the blue values are, which is great, and we'll be referring to that in just a moment. Before we do, this is just a quick function that I found on the internet that allows you to send emails, in this instance from Gmail. You can set this up. You do need some sort of weird special password that's different to your password, but if you Google how to set this shit up in Python, this send email function, however the hell this works, SMTP send mail. If you Google this, it'll explain all this. I just copied and pasted this basically, but it allows you to send an email from Python. Now this is the real juicy part of the script where it all happens. Now as I mentioned before, the presence and location of low, medium and high clouds is what's going to determine whether or not there is a decent chance of there being a good sunset or sunrise at all. So I've said that in order for there to be a decent chance of a sunset that's going to occur, there needs to be not much low cloud in the center south pixel here. So let's say I'm standing here and I want to look at the sunset, which is out in this direction to the west. this is saying that I want not much low cloud, as you can see by this less than -100 value here. Not much low cloud in the center south right in front of me. I want not much mid cloud in the center south or southwest. So that's these pixels here, not much mid cloud here or here. And then I do want some high cloud, as you can see by the greater than -200 here, some high cloud here in center south. So that's going to be the high cloud that the sun projects onto with the orange red glow in order for you to see down beneath. And then finally I've said that there needs to be not much high cloud further out here to the southwest west. So if you imagine that for a second, I'm basically saying there's not much here to obstruct your view, there's a big gap out here for light to come in, and then there's high cloud for that sun to hit. Now if you think of that little picture of the sunset we saw before, that basically lines up with that. So we've got all this high cloud here, there's no low or mid cloud out in that direction, and the light's able to come in and illuminate the underneath of the high cloud here. You imagine if this high cloud extended all the way out here beyond the horizon, it would essentially block, the cloud would block itself from getting light, but because the cloud ends here, there's lots of space down here for the sun to shoot up and illuminate it here. So that's basically what this if statement here is asking. Are the conditions all perfect? And if they are pretty damn good, then it sends an email saying, yeah, there may actually be a sunset tomorrow. And just for context, I've made the email also include all of the values, just so I can sort of double check, okay, is it true that the amount of mid cloud that's a bit further away is this? Just so for a bit more understanding of why the hell it's telling me there might be a sunset. And of course, if there is just maybe a lower chance of there being a sunset, and it's not really as confirmed as this, I've set up a sort of a maybe. This is like a sort of a maybe if statement, in that, oh, there may be a sunset, but it's not really set up perfectly. Who knows? We'll find out, is what this one's saying, and it will send another email saying that, you know, there's potential for a sunset, but it's not as likely. And then there's similar setup for the sunrise as well, where all the parameters are set up in a kind of similar way, saying that there needs to be the right setup of high cloud, mid cloud, and low cloud looking out to the east for the sunrise in order for these parameters, this if statement here, to be met. And then it will go and send out the email. So that's pretty much it. Like I mentioned, this is set up for me at the moment in the location that I'm in, and if you're elsewhere in the world, then you will need to, for starters, use a different website, and maybe if there's a different color scheme than red to blue, which they're probably, you know, that's probably going to be the case, then you're going to need to change this code somewhat in order to make it work for you. But I'm just using this as a general guide to explain, okay, this is how you can use code somewhat like this in order to make some sunrise sunset detection. Now, the way you automate it is you set up a bat file pointing to the script. So I'm going to have a look in my bat file. It's very simple. All it does is it says change the directory to where the Python script is located, and then Python, then that particular script, which by the way I need to now rename. Give me a moment. Yep, done. And so what you can then do is set up this bat file here in Windows Task Scheduler, so you can have this script, this Python script, scheduled to run at a particular time every day. You can set up, I believe, in Windows Task Scheduler, such that if you aren't at the computer at the time that the script should run, you know, let's just say you're an hour late getting home or something like that, you can set it up so that it will run late, which may be better than not running at all. It depends on how you've set it up and what images it's going to refer to and whether they might be outdated by the time that you get home. But the point is that you don't, if you aren't home and you don't have your computer on when the bat file is set to run, you can make it be delayed for when you start up the computer next. Regarding setting this up in the cloud, I did notice that you could probably set this up in Google Colab, but they charge some bullshit. It's like $60 a month or something like that. I decided it was too much, and I was happy to just run it from my computer when I happened to be at home with the computer on. So that's pretty much that. If you guys have any questions on any of that and how this script could be changed to make it work for you, please leave some comments down below. We'll see what we can do to help you out. Let me know how you go, and if this happens to actually help you find or detect any upcoming sunsets and sunrises. I'm going to be honest, I actually had this thing tell me that there was an upcoming sunrise not too long ago, and I decided I couldn't be asked getting up early because it was like 6 AM or some shit. And sure enough, I looked at the webcams for earlier that morning while I was still asleep, and there was actually a pretty decent sunrise. So it actually did a fantastic job at predicting that there would be a good sunrise, albeit the sunrises I saw were a little bit further northeast, the webcams. I didn't actually have a webcam for where I am located, but the point is that there was a decent sunrise within my general area when this script was saying that there would be a good sunrise. So the first instance of this has proven to be fairly successful, even though I haven't confirmed it in person. So yeah, anyway, let me know how you go and if it works. If it doesn't work, how this could be improved. Maybe you could take this script and make it better. You can make it more automated. Do keep in mind that this is only set up to look for sunrises and sunsets as if they're coming from directly west or directly east, which we know is not true. For example, down here during the summer, the sun rises more to the south, and during the winter the sun rises more to the north, so it's not going to be the perfect right angle. So that's why this is not the perfect script. It could be a whole, it's like I said, it's very coarse, very rough, but obviously you could probably improve it with some serious technical skills if you wanted to. So anyway, good luck with it. Leave some comments, and I'll talk to you next time.